In the previous models, we have learned how to fit a regression model to variables which had values continuous. In case of simple linear regression model, we had one respondent or one dependent variable which had continuous values, and we had one predictor variable which had continuous values. And in case of multiple, we had one dependent variable with continuous values and a number of predictor variables, all of them continuous. However, sometimes it so happens that our response variable or the dependent variable only takes the two values 0 and 1, and we have a set of predictors which take continuous values, and we would like to fit a regression model to this predictor. We would like to fit a regression model of this response variable or dependent variable on the set of predictors. In such cases, using the regular regression model does not give us good results. What we would now like to do is fit some special regression models. Some of them are Logit, probit and Tobit model. In this module, we will discuss the introduction of Tobit model in order to fit a regression model to a variable which is categorical on a set of predictor variables. In this module, we will be discussing the Tobit model. This is not a very commonly used model in regression. However, they are increasingly becoming popular in fitting regression model to sensor data values. So, when we wish to study a dependent variable as a function of several independent variables, in other words, when we want to regress a dependent variable on a number of independent variables, then we use a regression model if both the regressors and the regressant are continuous. Sometimes it so happens that the dependent variable is dichotomous. By dichotomous, we mean it's a variable which can take on two values, either 0 or 1. In such cases, we have to use special models that enable the interesting estimation problems associated with such models. Some of the most commonly used models to fit to data that have dichotomous response variable are Logit and probit model, and they are extensively studied in statistical fraternity. However, a more uncommon or lesser known model is the Tobit model, which comes in handy when we have censored data for the response. For example, if we want to study the labor force of adult males as a function of the unemployment rate, average wage, family income and education, etc. Here, the response variable is the labor force participation. This variable takes the value 1 when the individual participates in the labor force and takes the value 0 otherwise. And as we can see, this is our response, and the possible values that it can take are 0 and 1. And we wish to regress this on a bunch of continuous predictor variables. Another example could be that we wish to study membership status of college professors as a function of several qualitative and quantitative predictors. So, a college professor can either be a member of a union, which will denote the value 1, and can be not a member of a union, which will be denoted by 0. So, our predictor variable are the continuous variables. However, the dependent variable here takes the value 0 and 1 and is dichotomous. So, consider the home ownership example. Look at the following data set, and it gives us y equals 1 if the individual owns a home and 0 otherwise, where y is our response variable and x is the predictor variable, which is income in thousands of dollars. Now, in case of dichotomous data, we model the condition expected mean y, which is nothing but the probability. So, as I have mentioned before, in case y is dichotomous, then the expected value of y given the predictor value x is nothing but the probability that y takes the value 1. Now, as you remember, expectation y given x equals alpha plus beta x, where alpha is our intercept parameter and beta is our slope parameter in case of a regression setup. Now, if we want to use the same setup here for the expected values of y, then we will see that since expected value of y given x in case of dichotomous variable is nothing but probability, so the range of values that it can take is between 0 and 1. However, the predictor variable x is continuous and the right hand side alpha plus beta x can now take any value over the range negative infinity to positive infinity. So there is a problem of fitting the linear regression model to a setup where the response variable is dichotomous or takes values 0 and 1, because that way we can end up with a prediction of y which is outside of the range of y. So what we do in practice is we either use a Logit model or a probit model which uses the help of a link function so that we can maintain the range of data values on the right hand side as well as left hand side of the expectation of y given x in a regression setup. In case of Logit model, we use the CDF of a logistic distribution, which is 1 over 1 plus exponential negative alpha plus beta xi. So what happens here is, in regular regression we had expectation y given xi equals alpha plus beta xi, but in case of Logit function, Logit link, it gives us expectation of y given xi equals 1 over 1 plus exponential negative alpha plus beta xi. And similarly, in case of probit model, we use the probit link function which uses the normal distribution CDF as the link function. An extension of the probit model is the Tobit model, where Tobit model is coined by James Tobin, and he was a Nobel laureate economist. So let us now go back to the home ownership example. If we are interested in knowing the amount that a customer is spending on buying a house in relation to his or her income, then this data is only available for individuals who bought a house. Thus, to handle such situation, we divide the entire population under study into two groups. One for which I have info about the regressor and the regressant, and the other where only data on regressor is present, but regressant, which is the dependent variable, does not give us any values. So the first group has N1 and the second has N2 individuals. In a sample where we have values of regressant only on some individuals, such data are called censored, and such sample will be called a censored sample. A model to fit such data is a Tobit model, where we have certain values for the regressant or the dependent variable. However, some other values are missing. So a model to fit such data is Tobit model, or the limited dependent variable model, which is also another name for this class of models that fitted to data. Now, because of the restrictions on the values of the regressant, this model is called a limited dependent variable model. Mathematically, the model is written as follows. It is given by yi equals beta 1 plus beta 2 x2i plus u2i, where u2i is the error term, if the right hand side is greater than 0, and yi equals 0 otherwise. We cannot estimate the regression using just N1 from the first group, and this is because if only N1 observations are used, then expected value of ui may not be 0, and without expected value of ui equals 0, the estimates of the coefficients cannot be proved to be unbiased. And when we find the estimates of a regression parameter, our idea is to find an unbiased estimator and a BLUE, which is the best linear unbiased estimator having the minimum variance among the class of unbiased estimators for the regression estimates. We cannot estimate the regression using just N1 from the first group, and this is because if only N1 observations are used, then expected value of ui may not be 0, and without expected value of ui equals 0, the estimates of the coefficients cannot be proved to be unbiased. And when we find the estimates of a regression parameter, our idea is to find an unbiased estimator and a BLUE, which is the best linear unbiased estimator having the minimum variance among the class of unbiased estimators for the regression estimates. Now, from the following figure, we can see that in the group where y is not observed, which contains n2 observations, they will lie on the horizontal axis. They are marked by the x's along the horizontal axis. And if the y is obtained, the observations will lie on the y and x plane. Now, from the plot, it is clear to us that if we estimate a regression based on the n1 observations only, the resulting intercept and slope coefficients are bound to be different from when n1 and n2 are taken together. So, there is special care that needs to be taken when we wish to fit a Tobit model to a data set. Now, how would we want to estimate the parameters? Let us now look at the latent variable interpretation of these special models, which are Logit, probit and Tobit model. Now, suppose the dichotomous or the binary dependent variable that we were talking about depends on an unobserved utility index, which we denote by y star. If y is discrete, that is dichotomous taking values 0 and 1, suppose for example in case someone buys a car or does not buy a car. In that case, we can write the model formally as yi star equals beta naught plus beta 1 x1 I plus epsilon I, where epsilon I is the error term and yi star is now the unobserved utility index, which has replaced our dependent dichotomous variable yi. So, if the utility index is high enough, a person will buy a car, which means yi will take the value if yi star is greater than equals 0, and if the utility index is not high enough, a person will not buy a car, that is y will take the values 0. So, in the Logit and probit model setup, we have the probability I as probability yi equals 1, or in other words probability yi star greater than equals 0, and yi star, as we know, has been written as probability beta naught plus beta 1 x1 I plus epsilon I greater than equals 0, and we have already seen this relationship of beta naught plus beta 1 xi plus epsilon I greater than 0 implying yi equals 1 when we defined the mathematical form of the Tobit model. So, the basic problem here is we can write pi equals probability epsilon I greater than negative beta naught minus beta 1 x1 I by rearranging the terms, which stands as 1 minus capital F, which is the CDF of negative beta naught minus beta 1 x1 I, where F is the CDF for the distribution of the error term, which is normal. So, the basic problem is selecting F, which is the cumulative density function for the error term. For Logit model, we specify that probability yi equals 1 equals 1 divided by 1 plus exponential negative beta naught minus beta 1 x1 I. So, probability yi equals 1 goes to 0 as beta naught plus beta 1 x1 I goes to negative infinity, and probability yi equals 1 goes to 1 as beta naught plus beta 1 x1 I goes to positive infinity. Thus, the probabilities from the Logit model will end up being between the range of probability, which is 0 and 1. And in case of probit model, we assume the error in the utility index model is normally distributed, and as I have mentioned before, we use the CDF of the normal distribution. So, probability yi equals 1 equals capital F of beta naught plus beta 1 x1 I divided by sigma, where F is the standard normal cumulative density function. Now, in case of Tobit model, we can also have latent variable models that do not involve binary dependent variables. Suppose we have y star equals x times beta plus u, where the distribution of error term u given x follows normal 0 sigma square. But what we observe is that y equals max of 0 and y star, which means the Tobit model uses MLE to estimate both beta and sigma square. And it is important to realize that beta estimates the effect of x on y star here and not our dependent variable y. So, we are actually estimating beta as the effect of x on our latent variable y star and not our actually dependent variable y. So, how do we estimate the parameters in a Tobit model? So, if we write the probability or the expected value of yi equals 0 given xi equals probability xi beta plus epsilon I less than equals 0 given xi, that equals probability epsilon I less than equals negative xi beta by rearranging the terms. So, we can write this as dividing both sides by sigma, probability epsilon I divided by sigma is less than equals negative xi beta divided by sigma given xi, which in terms of the cumulative distribution function of normal distribution is written as phi of negative xi beta divided by sigma. So, probability of yi greater than 0 given xi would be 1 minus phi of negative xi beta divided by sigma, and using this form we obtain the maximum likelihood estimates of the parameters beta. We can also fit a Tobit regression model using R. There are packages such as AER, which uses functions Tobit to fit a Tobit regression model to a data set, or we can also use CENS regression or censored regression function in R to fit a regression model to a data set which has censored values for the dependent variables. But we will dedicate a separate module to the discussion of fitting a Tobit regression model to a data set using R. In this module, we have learned how to fit a Tobit regression model to a data where our response variable is categorical and it can take two possible values 0 and 1. And we have illustrated using an example of how to fit a regression model and how to estimate the parameters involved in a Tobit regression model. We can also fit a regression model using the Tobit setup in R, but we will dedicate a separate module to that discussion.